This is the lesson for Chapter 6, Section 2, titled Representations of Functions. And so we're going to take another look at a function rule here. Remember I had talked about before, a function is when each input has exactly one output. And here a function rule is an equation that describes a relationship between inputs and outputs. And yes, it does. You see, if we have an input of -2, we should always get the same output. And here the rule is y equals 3x. So the rule says that we're going to take our input and always multiply it by 3, and then we're going to get an output. And that's true. So -2 in for x here, and we multiply it by 3, we get an output of -6. And so that's what a function rule is. And again, a function is when we get the same exact output every time that we put a specific input into the function rule. And so what they want us to do is write some function rules, and we're going to use y to represent the output, and we're going to use x to represent the input. And so here it says the output is 4 times the input. Is a word that represents equals, and so we're going to write y in place of output equals 4 times the input, so 4x, and that would be our answer. Well, over here it says the output, which is y, is means equals 8 less than the input. 8 less than means that I'm going to take 8 away. So 8 less means -8. So I need to take 8 away from that input. So it's got to be in this form here. Otherwise, if we had switched it around and did 8 minus x, this would be x less, or the input less than 8. And so that would be wrong. So we've got to write it as 8 less than the input. Well, here we're trying to find some values of y given the input value of x. And so we're just going to substitute, put 12 in place of x, and see what we get. So y equals 12 over 3, which just gives us 4. And over here, if I had y equals 5x plus 9, I'm substituting the 2 in for x. And so I have y equals 5 times by 2 plus 9. And so that leaves me with 10 plus 9, which ends up being 19. And so y is 19 when x is 2 in that equation. Well, we've got some other types of problems. Here it says you set up a hot chocolate stand at a football game. The cost of your supplies is $75. You charge 50 cents for each cup of hot chocolate. Write a function rule that represents the profit of selling C cups of hot chocolate. And so here it says the cost of supplies is $75. So that means that we have to pay $75. So we're going to take that away from our profit. And so 50 cents, this is the profit. So this is for each cup. And so the key word here is for each cup. See, we've got two different components of this, two different units. They're comparing 50 cents per cup. And whenever we're asked to find that expression, so we're asked to find how many cups it's going to end up being before we're going to end up breaking even eventually, that's going to end up being our variable term. So we're asked to use C for cups, and so we'll go ahead and do that. So P for profits, so P equals, and that's in place of the Y this time, 0.5, so 0.5 times by the number of cups minus $75. And so that's going to be our function rule for this situation. And here it asks us to find the break-even point when the cost of your supplies equals the income. So we want to find the amount that'll make this 0. So we want profit to equal 0. So that's what we're trying to find then. And we're going to go ahead and find out the number of cups that makes that the case. So 0.5 C minus 75. So we go ahead and do some opposite operations here. We'll add the 75 to all sides. And that leaves us with 75 equals 0.5 C. So we're just going to divide by 0.5. And when I do that, I end up having to move that decimal point over in the divisor and then add a 0 to the end of the dividend. And so it's really 5 into 750 is what we ended up doing there. And so the decimal point comes straight up. 5 goes into 7 one time with 1 left, or 2 left over. Into 25 it goes 5 times evenly, but I still have that extra number in the quotient I need to put in there, so I'll use a placeholder of 0. So it looks like it's going to be 150 cups until we end up breaking even. After 150 cups we make money. So let's take a look at the next one here. Here we have to, it says the number of pounds P in carbon dioxide is produced by a car is 20 times the number of gallons G of gasoline used by the car. So we're supposed to write and graph the function that describes the relationship between G and P. So the number of pounds is dependent upon, the number of pounds of carbon dioxide is dependent on how much gas you end up using. So it says that the pounds is, again, is a key word there, it tells us equals 20 times the number of gallons, so 20G. And so there is our function rule. And so now we're going to graph that. So I'm using G as the independent variable, and so the gallons of gasoline will go on the x-axis, and this is actually my g-axis I'm using, and here's my p-axis, and this is pounds of CO2, carbon dioxide. And so I'm going to go ahead and use, since I've got lots of space here, I got to go 20 times, so I'm going to go by 20s. I'm going to call this one 40 right here, and this would be 60, this would be 80, this would be 100, so 120, so this would be 160, this would be 200, 240, and 280. And so I'll count by ones this way, but I'll just write every other number. So 2, 4, 6, 8, 10, 12, and 14 will go. And so now they're asking us to graph it. So when I graph it, I'm going to just use the slope-intercept form. So there is my slope. The slope of the line represents 20 to 1. And my y-intercept, well, that's just 0. I'm starting at 0, so that's my y-intercept. And so I'll start at 0 and then just use the slope. I'm going up 20 over 1. Now again, I'm counted by 20s on my p-axis, on my pounds axis, and counting by ones on my gallons axis, so you can see how the line's going to kind of come up at an angle this way. And so that's what the line will end up looking like. Well, let's take a look at the last one. It says you want to take a 2-hour airboat tour, it says, and you're supposed to write a function that represents the cost G of a tour at Gator's Tour. And so here's Gator Tour right here. And they tell us, so the cost G is equal to a boarding fee of $35. So this is the constant amount. That's your y-intercept. So there's my y-intercept. I have that. That's the initial amount. So you pay $35 just for getting on the boat, and then you pay $5 each half hour. So I'm going to use H for the number of hours. Number of hours. Well, if I had 5.5 hours, so $5 for per half hour, that I want to change it to hours. So that's going to be $10 every hour is what that's going to end up being. So I'm going to write down that this is 10h. That's the rate of change. So that's the first equation. Now we're going to write a function for S, for Snake Tours. And so Snake Tours is down below here. $25 per hour. No boarding fee, though. So we have a 0 as the boarding fee, and it's $25 an hour. So you can see how it's more expensive to go on Gator to start with, because you got to pay $35 just to board their boat. But eventually they're going to be less because their rate is less than Snake Tours. So we're going to find out who is the better deal at 2 hours. So what we can do is we can substitute. We can take 2 hours and substitute in for h. So I've got G equals 10 times by 2, because we know we're going to take a 2-hour boat ride, plus $35. And so that's going to be 20 plus 35, and that's going to leave us with $55. That's going to be the cost at Gator Tours. Where at Snake Tours, $25 times by 2 leaves us with $50. So at 2 hours, it's going to be $50 with Snake Tours, $55 at Gator Tours. So I'm going to go with Snake Tours. Snake Tours went for a 2-hour ride, 2-hour tour, I'll say, because the cost is $5 less. And so you can see how Snake Tours is $50 where Gator Tours is $55. So those are the types of problems you're going to end up seeing on tonight's homework. Good luck.